Right, so in this problem, we want to approximate this value right here using midpoint Riemann sums with 3 subintervals. So when it says 0 to 12, that means the entire thing. We want to approximate all of it. So just a great thing to start. Again, it's just to sketch a little graph. Again, it does not have to be accurate. We are just sketching. It's just to give us a visual. So I'm not actually going to make this to scale or anything. I'm just going to sketch and then label. So at 0, we're at 11, 2, 30, 4, 54, 5, 26, 6, 21, 9 is 44, and 12 is 0. Since 12 is 0 for visually, I'm just going to go ahead and make it down here and put 0. That may make it better for you guys. I'll erase this just so you can see it better. All right, here we go, trapezoid sums. So we're going to use, midpoint sums with 3 subintervals. So that means I need to break this up into 3 pieces. If you look at this chart up here, here's 1 piece, here's 2 pieces, and here's 3 pieces. So down here, 0 to 4 looks like the first piece. And the subintervals don't have to be the same, but I do want to get the midterm, and since I'm with a table, I'm going to go in the middle, which makes this 2 the midpoint. And then if I go 3 more, I'm going to go over to 6, and that would make 26 in the middle. And then last but not least, 12, and that would make 9 in the middle. And I can draw my 3 triangles or rectangles. So here's my first one, that's rectangle 1. Here's my second one, rectangle 2, and here's my third one, which is rectangle 3. So the width, that's important to get the width. The width of the first one is 0 to 4, so that is the width of 4. The width between 4 and 6 right here is going to be 2, and between 6 and 12 it's going to be 6. So it's important to know my widths. So for the area of a triangle or rectangle, actually all I do is area, and that is length times width, right? So I've got 3 of these. So for my first one, the width or the length or the height is 30, and the width is 4 plus, and the height is 26, and the width is 2, and the last one, the height is 44, and the width is 6. And so that is the area of these 3 rectangles all together, which approximates the area under the curve. So when you calculate that all up, you get 438. Okay, so what does the 438 mean? Let's look back if we want to use correct units and interpret your answer in context of the problem. So, and this was a rate, so it was people per hour. So if we go backward, we're actually looking at people. And what about the people? So people enter the store. This is the rate that people enter the store. So we're talking about people. So there were 438 people that entered the store from, now you can say over 12 hours, or I'm going to say from time equals 0 to time equals 12. And that's it. So if we look at the table, just to see what we did, we had 3 different divisions. So this is the first rectangle we used. We want to use 3 rectangles. So, and then here's the middle of that rectangle. For the next rectangle, we used this rectangle, and here was the middle of that rectangle. And for the last rectangle, we used this one, and here was the midpoint of that rectangle. It's a little different when you use tables. This time we're going to do a trapezoidal sum. And so don't forget the formula for the area of a trapezoid. Remember, if we have a rectangle, it is just length times width. But if we have a trapezoid, then we still have the width, but we have 2 different lengths. So how do we decide which one to use? We don't. We use them both, and we average them. L1 plus L2. We take the average, and then we multiply it by the width. So don't forget this formula. It's really helpful. I usually write the 1/2 outside of it. And you can even put the W on top to like make it super nice and neat. And then L1 plus L2. All right, so again, we're gonna make a little sketch. Just does not matter, not to scale, we just sketch. And then I'm gonna label it. So 4 is 54. And at 5, we have 26. And 6 is 21. And then at 9, we're back up to 44. Oh, look at my sketch being kind of accurate. And we're using 4 trapezoidal sums. So let's draw those in now. So here we go, 1. Oh, actually, we're going to have how many? It looks like we're going to have 3. 1, 2, 3 trapezoids. We're going to get the area. So that just means, and let's get the widths also. So let's do the widths. The widths of each of these are 4 to 5 is 1. And that's a highlighter. 4 to 5 is 1. 5 to 6 is 1. And 6 to 9 is width 3. So we do have some varying widths here. So the first thing we're going to do always is our 1/2. So this is approximately 1/2, big parentheses, and then we're going to do the math. We have the first trapezoid, which is going to be right here. So it's 54 plus 26. And that width is 1, love it. I'm out of room, so I'm going to go down here, plus, here's our second trapezoid, 26 plus 21. And that width is also 1, awesome. And last but not least, here's our third trapezoid, and those heights are 21 plus 44, but this time our width is 3. So be sure to put a 3 right here. So what you're going to do now is you're going to do all of this math and then divide it by 2. Okay, I used my calculator and I got 161. And what are we talking about? People again. Enter the store, or entered the store, from time equals 4 to time equals 9. And the most important part of this is showing these sums, okay? So if you don't have a calculator and you didn't want to do this, you don't actually have to, as long as you show the sums. All right, have a great day.